Inertia is defined to be the sum over all the particles in the system of m sub I times the distance r sub I squared. Now the proof of this is in the lecture notes. I'm not going to do it here. I just want to give you some experimental evidence that the moment of inertia depends not only on the mass but on the distances. See, how do I think of rotational mass? How do I think of moment of inertia? Well, how do I think of regular mass? Regular mass is a measure of how hard it is to accelerate something. If something's got a huge mass, it's really hard to accelerate it. Similarly, if something's got a huge moment of inertia, it's really hard to give it a big angular acceleration. I've got to apply a huge torque if I've got a huge I and I want a certain alpha. So I have a little demonstration here, and for this demonstration I'll need a volunteer. Too bad it's not Halloween, so we could get a colorful volunteer, but I need a volunteer with a very powerful wrist. I have skinny wrists. Look at that. I've always had trouble developing my wrists. I need someone who's a tennis player or a football player, or I don't know, someone who's got a big wrist. If you don't have a big wrist, just volunteer your neighbor. Who's got a bigger? This guy right here. Come on down. Oh yeah, I can tell. He's got a bigger wrist than me. What's your name, sir? Mason. Mason, grab that. Come on over here. Stand by me. Mason, grab it at the middle, the 50-centimeter mark, and point it so that the discs are facing the audience like that. That's it. That's good. Now we're going to play a little shadow game. You stand behind me, okay? And it's going to be like me and my shadow. Whatever I do, you're going to do exactly, okay? So if I twist this thing to the right, you're going to twist it to the right the same angle. And if I twist it to the left, you're going to twist it to the left the same angle, okay? So I'm just going to twist it back and forth nice and slow. Okay? How's he doing? Okay? So I'm going to pick up the pace just a little bit. Just a little bit. Is he still keeping pace? Okay? Now I'm going to pick up the pace just a little more. You ready? Here we go. How's he doing? Come on. Oh, you can do better than that. Come on, come on. Okay. I noticed you couldn't keep up, Mason. Was it really hard? Oh, yeah. I was sure Mason wouldn't be able to keep up because the distance of his masses from the center is 4 times the distance of my masses from the center. And in the formula for moment of inertia, the distance gets squared. So his moment of inertia is 16 times bigger than mine. So I could tell Mason was stronger than me, but I was pretty sure he wasn't 16 times stronger. So I knew he wasn't going to be able to keep up. But let's have a hand for Mason, strong-wristed Mason.